Hi, it's Mr. Anderson. Today I'm going to talk about the fight or flight reaction. This is one of my favorite videos on YouTube. This is from youtube.com/Russia Today. So we got this person here walking down the street. All of a sudden they realize there's a car coming, and then they get out of the way. Now, if I were to keep playing it, the guy jumps out of the car, comes running in this direction. But basically, I want to talk about what's going on. So once this guy sees the car, how does he, number one, get out of the way? And then how does that affect his body? How does that affect the organs and the chemistry and all of that inside his body? And so that whole thing is called the fight or flight. And so when I ask students, how does he get out of the way of the car? The answer is always adrenaline. And the right answer is no, it's not adrenaline. Adrenaline's not going to be able to get there that quickly. And so how does a guy really get out of the way? Well, he's going to see the car coming. He's going to process that in his brain, and then he's going to send a message down his nervous system. That nervous system is going to be attached to muscles, and those muscles are going to have ATP ready to go. And so the way he's able to jump out of the way and not get hit by the car doesn't have anything to do with the fight or flight response. It's simply his nervous system, his muscles, and just responding to that threat immediately. But if you've ever been in a situation like that where you just barely survive an accident or something like that, all of a sudden you feel this rush of just your heart starts beating faster, you're breathing, you feel warm. Now that's part of the fight or flight response, because this guy right here, since he's living in a city, is able to just kind of walk back onto the road and keep about his business. But back in the day, if you were attacked by a mountain lion or somebody else, you had to fight now. You had to flee, or you had to attack the attacker. And so all of that is part of what's called the sympathetic nervous system, or that system inside our body that allows us to fight or flight. And so let's zoom inside this guy and talk a little bit more about how the fight or flight works. And so it's basically centered around his brain. And so in the center of his brain, near the bottom, we have something called the hypothalamus. So the hypothalamus in that area of the brain is essentially going to send a signal. Now that signal, not only are we getting signals that are going to the muscles that allow you to move, but it's going to send a signal all the way down, a nervous signal all the way down here. Because in the center of our adrenal gland, we have something called the adrenal medulla. It's connected nervously to the brain. So the moment he sees that car and realizes he might die, there's a signal being sent to the adrenal medulla, or the center of the adrenal gland. It's going to give off what's called adrenaline, and that adrenaline is epinephrine. Epinephrine is a chemical signal that is going to be attached to the circulatory system, and so it's going to course through the body. So as his heart beats faster and faster and faster, epinephrine is going to flow throughout the rest of the body. Now, epinephrine is not going to go into the cells of the body. It's simply going to, if we say this is a big liver cell, it's simply going to bind to proteins on the surface of those cells. And so what's it going to do to the liver? Well, in the liver, what it's going to do is it's going to trigger a signal transduction pathway that's going to convert glycogen that's found inside the cells of the liver, and it's going to release that as glucose. Why is it doing that? Well, glucose is our energy supply, and so now glucose is going to be coursing through our body along with epinephrine, and so now we have a supply of energy, so we can quickly break down that glucose, get ATP, and we can do more out of it. But what's interesting is that epinephrine is going to go other places in the body, and it's going to have different responses depending on where it goes. And so what is epinephrine going to do to the cells that are in control of the breathing, the cells of the lung? It's going to speed up that breathing rate. What's epinephrine going to do when it goes to the cells of the heart? It's going to speed up the rate of the heartbeat. And so it's going to trigger a signal transduction pathway in the heart that's very similar to the signal transduction pathway that we find in the liver cells. However, it's going to have a different response inside the cells. It's going to not release glucose, but it's going to increase the rate of the beating of those cardiac cells. What do you think it would happen to the digestive system? Well, epinephrine's going to go there. Epinephrine's going to go there as well. But what it's going to do is it's going to vasoconstrict. So it's going to slow down digestion. And so it's going to slow down those blood vessels that feed those areas that allow us to break down and digest food, because when you're getting out of the way of a car or fighting an attacker, you don't really need to concentrate on breaking down that bagel that you ate for breakfast. So it's going to shut that down, but it's going to go to the muscles of your body and it's going to vasodilate, and so it's going to move more blood to those areas. And so our whole body is designed so we can have one signal, that epinephrine, but it can have all these different responses throughout the rest of the body. And so that's going to allow our body to respond to that threat, and that's why your heart races, you breathe faster, your pupils dilate, all that happens, and you can thank epinephrine for that. And it's that chemical response and the different either gene expression or signal transduction pathways that we have as a result. And so I hope that's helpful.